if you didn't go, also I think it just started recording, by the way. I'm pretty sure. Do you guys see the recording thing, like saying that it's recording? Yeah. Yeah, okay, cool. Okay, so we're recording now. Hey guys, what's up? It's Christo. Sitting here with the COP3503C final review. Hold on, wait, what? Bruno? Breath. Okay, I'm reading the chat just so you guys know, for anybody watching the recording later on, maybe. They're talking about how they got ducks. But anyways, so yeah, we're here for the final review. I'm just gonna be going over a quick presentation that I put together that I tried to basically make follow along with the review that was posted on Canvas. Then after I go over the review, which I'm hoping that the PowerPoint won't take me too long, I'm then planning to basically go over any questions that you guys have, like from the practice exam, that maybe you don't understand, and I can try to explain them logically. I have another camera set up with like a whiteboard, so like I can like write stuff out for you guys and like try to like visually show everything. So yeah, we'll just get started with the presentation here. If you guys have any questions, feel free to type them in the chat. Obviously, if you're in person and you have a question, feel free to just like shout it out, because like, you know, like no reason not to. So yeah. All right, so once again, like you'll notice like the general structure of this presentation, it just like goes along with the how the review was laid out. So like I didn't really like choose most of the order of the presentation. It's just kind of like what was there. But so the first thing it talks about is iterators. Now for iterators, guys, I decided it was better for me to just show like a code example and explain exactly what it's doing. So now, first of all, when you use iterators, like one of the most common reasons you would use an iterator is if you have some form of like unordered data structure, data set, whatever. For example, a map is not ordered. Like it's not like you have an array where you have like 1, 2, 3, 4, 5, and you have like contiguous spots in memory. You just kind of have a key. So like you got to find some other way to iterate through the items in a map other than just like adding a number to something. So that's when you would use an iterator basically. Now you need to know how to create or initialize an iterator. Welcome. And when you make one, so you can see that in this coding example, if we look here, you can see that there's auto and then the word iter, which is just like the name for it. That doesn't actually matter. What auto does is it's basically looking at what something is being set equal to, and then basically the compiler is automatically figuring out what the data type should be. You can see I have a comment there that shows if I didn't type auto, what you would actually have to type, which is map intent iterator, to make it this correct type. Now, when you're using iterators, you need to use .begin and .end to test, like, well, you know, you want to start at the beginning and then you go to the end, and then basically it's going to look at the keys of in a map. It's going to look at the key and it's going to print everything out basically, like, or go through it basically in like alphabetical order, or like if your key is like ints, it's going to go like from ascending order, starting from lowest, go to the highest, etc. So this is important for iterators. Something that's important to keep in mind is like when you have an iterator that's like not just going from an int, it's going to go in like basically like ABC order, because it's going to go by the value of the character. And obviously, you know, if you go up and down with the characters, it's usually just ABC order, unless you have like something that's like lowercase and uppercase, then it'll go like, I think uppercase is first usually. No, lowercase might be first. No, uppercase. I don't remember off the top of my head, but one of those is first. I don't think you guys will need to know that though. But anyways, so yeah, we like go to the output of this code. If we look at what it's actually doing. So that's why maps are alphabetic when you print them. Yes, that's why they're alphabetic. Like I think in the practice exam, there was an example, and like you notice that like the actual correct answer, like I think it was like with cities, right? So the first one was Anchorage, because Anchorage starts with A. Kyle, does that make sense? Yeah. So yeah, here's the data. So like if you look at this code, right, like I have the iterator and I basically just have it going through this map that I made. You can see that there's the keys, which is the 1, the 5, and the 7, and there's the 2, the 10, and the 14, which are the data types. Now it doesn't matter what order I place these in. I could do like the 7 first, but it's gonna print these out like 157. So like when you look at the output, there you go. So yeah, that's that. Are there any like, hopefully like, was there anything in this code that you guys didn't understand by like my explanation just now, or is there anything that you guys need help with or no? All right, cool. I'm gonna move on from iterators. Next up, we got pointers. Now, pointers are gonna be a huge thing, and there's not really like a way for me to just like automatically get you guys all the information about pointers because like there's so many different ways, like tiny little differences you can. So if you initialize the iterator before the loop, you don't initialize it in the for loop. Yes, that's correct. So like if I go back to this code, then you'll see it's not initialized in the for loop. It's literally just a semicolon there. If I initialize it in the for loop, obviously you just have basically that you would have the line above it. You would have it inside the for loop. Milana. Yeah. So yeah, then pointers, like there's no way I can like just like tell you guys every single rule about them. Like that's just impossible. So I'll just give you guys the rundown, and like when we go over the practice exam, like we can like go over like the specific pointer questions, and like you guys can like ask. That way we see some like more specific examples. But so anyways, a pointer basically points to a memory address. And for all like intensive purposes, it basically is a memory address. For example, if you're going to pass something in as a parameter that is supposed to be a pointer, you're passing in a memory address. So like just think of a pointer as a memory address. And it's actually pretty simple once you kind of understand that logic. What you're going to do here is we're going to take to make, so this pointers also go into dynamic memory versus like static memory. So static memory is like stuff in the stack that you don't really control. It's just kind of automatically done. Whereas dynamic memory is like stuff that you do control, and it's basically you telling your program or your operating system or whatever. It's basically saying, I want you to reserve space for these variables. It's not creating new space. Your computer system already has all of its memory. It's not like you're like installing a new hard drive or anything, but it's basically saying, I want you to, once again, it's like a reservation. Like imagine your memory is a restaurant, bro. You got to make a reservation at that restaurant in order to like actually eat or something. So yeah, so in order to basically allocate, and once again, allocate just means reserve. In order to allocate memory, you're going to use the new keyword before something. And in order to deallocate, as in say, okay, we no longer need this memory, to be used for this, you're going to use the delete keyword. Now notice when you deallocate something, it's not that you're deleting the object that exists there. It's that you're saying this memory can now be overwritten if the operating system wants to. So when you delete something, you're not going to immediately delete what's there. You're going to basically just say that like this is no longer reserved. So you can use the heap, like especially like in like arrays. You'll notice that when you make an array, you oftentimes make a pointer. And then you basically make the pointer to like an array of whatever object you're making. And this will really help because if you're trying to make like a really big array, you don't want to like get stack overflow, which is basically where, the stack and the heap, the stack is a very low amount of storage, whereas the heap is a very large. So if you accidentally go over the total amount of storage that is on the stack, you have stack overflow errors. So that's why you would do this. You do this to avoid that. Now let's say you have an array, or let's say you have a pointer and that pointer is pointing to a dynamically allocated array. You need to use delete in the brackets. If you don't use delete and in the brackets, basically you're going to have undefined behavior. We don't really know what always happens. Like there's not like a specific thing, which is why once again in the practice exam, I think there was a question where you were like, it basically deleted an array not using the brackets, and the answer was just like you don't really know. And then finally, you have to know what a null pointer is. Null pointer, basically, it's a pointer object. It exists, but it's not actually pointing to an actual memory address. It's basically just sitting there. Like if you set something to null pointer, you're saying it's there, but not really there. But we might use it later, and we might reassign it later. So yeah, keep that in mind. That's the basic gist of a null pointer. Yes.
Wait, so this is a bit confusing me. So are pointers on the stack but point to something on the heap?
Right. So if you make a pointer variable and you don't use the like new keyword or anything when making the actual variable itself, the pointer itself is on the stack. But then oftentimes what it's pointing to is on the heap. And that also goes to another practice problem in that exam. I believe it like asked like how many dynamically allocated variables are in this function, and the answer was 0, even though there was a pointer to an array of like 3 dynamically allocated variables. Like the answer in that function was 0. So yeah, does that make sense? I mean, I feel like you could probably find a way to put a pointer, like you could dynamically allocate it, but like for our intensive purposes, yeah, pointers are usually going to be on the stack. you're correct. But like this, they could throw a curveball at you where they like make you like do like a new pointer or something, but yes. The pointer points to a pointer. So can you do that? That's a good question. A pointer. I feel like I don't think that pointer pointing to a pointer will be on the exam sheet. Don't worry. That would be a pointer pointing to a memory address. So like, I mean, you could maybe do that, but I don't know if that would really make sense. But anyways, so yeah, I want to see if there were any comments. You can use multiple dereferencing symbols to basically make a pointer. You can make a repeat pointer. Yeah, okay. Okay, guys, let me be real with you. I would not worry about pointers to pointers. Okay. Okay, cool. Anyways, so here's an example of some pointer stuff like that I just wanted to show real quick. So let's say I had, we have A is 5, and that's just a primitive data type. B is 6, which is not even being used. And those are both primitive. Those are both just normal, objects. Then we have C, which is going to be pointing to the address of A, guys. And then we have D, which is C. So notice when I made C, right? Because A is a normal, like non-pointer, like type, basically. Notice that A has to have a little and, the ampersand in front of it, because it's specifying that we're pointing at that address. Now remember what I said earlier, pointers basically are addresses. So that means when you set a pointer equal to another pointer, you don't have to have that ampersand right there. You're basically just saying it is the same memory location. Now, if we were to print out C there at the bottom, we're going to get a memory address because you have to dereference it in order to get the actual value that it points to at that memory address. So we're going to see when in the output in a second that it's going to print out a memory address there. And then below that, when we dereference D with the asterisk, then it's going to print out the actual value, which in this case should be 5. So yeah, do you guys see that? This is just like a screenshot of the code output. You can see like all those random numbers and letters and stuff. And if you set C equals A, so if you were to set C equals A, that like just A without the ampersand, like that wouldn't work, because then you're setting C, which is a pointer, which needs to be a memory address to just an int. So you're going to get an error, basically. Yeah. If we did star C, like star C, like that wouldn't really make sense, because I don't think, or wait, are you saying star C equals A, or like in the print? Oh, if you did star C in the print. Okay, so if you did star C, it would just do the same thing as star D. Like it would just dereference it and give you the value at C. Or the value that C is pointing to, rather. So it wouldn't just set it to the memory address that the int was. Paul, what are you, let's see, let me look at your previous, if we did, like if it was int 147, it wouldn't point to the address 147. Okay, here's the thing, it might actually point to the address 147, but I'm not 100% sure, but I would say that would probably just be undefined behavior. And basically you'll get some funky stuff if you do that. Don't set a pointer to just a variable. It won't work. Okay. Yeah. Make sure whenever you're setting a pointer to a, that would fall under undefined behavior, basically. So make sure whenever you set a pointer to something, you're setting it to an address, not a variable. So yeah, that's how that works. Okay, so then we have references. References, they're like kind of known as like the easier, more like, I don't know, like you don't have all this memory address stuff to worry about. Now, there are a few reasons why to use them. Like they basically do the same thing as pointers for the most part. Like, for example, if you pass a reference into a function as a parameter, and then you edit that that variable's value, you're going to get, that the value, you're going to actually change the value. However, there are a few reasons you wouldn't want to use them. So first of all, you have to initialize them. And second of all, you can't reassign them. So once you make a reference variable, like let's say I had, if I go back to this example, right? Let's say I set a reference, let's say instead of int, star C, or actually instead of int star D, I said like made D a reference by putting an ampersand in front of it. And then I just set it equal to like B or something, or A. Like it can't be reset to like the other variable anymore. It's like always the same thing now. So that's kind of like the point of, you can't really just go there and, you can't reassign it. So that's a slight issue. That's when you would have to use a pointer, but otherwise, you can use references because they're going to be easy, and like it's just like typing the ampersand basically, and then you treat it as if it literally is that variable. Yeah. So then we have OOP, object-oriented programming. This is kind of like, you learn this in 3502, and then you obviously learn in 3503 again, but in C++ it's a little bit more complicated. You're gonna, first of all, the whole basis of OOP is, encapsulating data, which that's a fancy word for basically just saying you're grouping a bunch of data into like one object. So, that makes sense. Object-oriented programming, you're creating an object with multiple types of data in that object. There's also so encapsulation would be one of the pillars. If there's like a question that's like, what are the 3 pillars? It's encapsulation. And then later we'll talk about inheritance and polymorphism. Those are the other 2. Also, like, we need to know, like, you make a constructor in that object to create an object. A copy constructor basically allows you to create an object with an existing object. So you're going to have the same values as an existing object, but it's going to be a different object. And notice that when you have a copy constructor, especially, you need to create your own. There is one that's default made, but you're going to need to make your own, especially if you're dealing with dynamic memory, because you might have slight issues if you don't. Now, a lot of people ask, like, what's the point of a copy constructor? Like, it doesn't really make sense. Like, why would you just copy something? Why wouldn't you just use that thing again? I always say, like, what if you want to like make an object that's like all the same values as something, and maybe there's like a lot of different values, except for like maybe one thing has changed, like one variable in that object's changed. So then you might want to just copy an old object and then change that one variable instead of making a new object and then have to manually put in every single data piece. Does that make sense to you guys as like the actual reason you would use one of those? Hopefully. And then there's also like, it's not seen on this slide, but obviously there's also the copy assignment operator, which is basically you take 2 existing objects, you take one existing object, or rather, and you set it equal to the data of another existing object. And then you have the destructor, which is basically taking care of dynamically allocated memory. It's basically saying, when this object falls out of scope, how do I actually deallocate this, the memory that I've allocated correctly? So we have the big 3. So now this example was actually straight from my midterm review, from some of the code, because I just decided to reuse it because why not? But so basically we have like a person class, and in the person class we have a few different like variables. Like we have their name, we have their age, we have their height, and that's it. So if we look at like, we make Joe, well, what's that using, guys? If we just make Joe, like put it in the chat. What is that? The first line 6. Okay, cool. So that's a constructor. Yeah, you guys got that. And then Joe.print data, that's just using a member class function. So now in line 9, you guys can see we have person Gerard equals Joe. What is that? Is this PowerPoint? I saw a question. Is this PowerPoint anywhere so we can follow along? Like, I haven't posted it. I'll be posting it after the session, like as a file. It should be being streamed right now, so you should be able to see it to follow along, Robert. I think everybody can see it for the most part, right? Yeah. So basically, so then if you look at line 9, you have person Gerard equals Joe. And like you guys said, that's a copy constructor. So I just wanted to look at the earlier slides because I came in late. Yeah, I'll like, here, let me see if I can like post it in the announcements real quick. Hopefully I post the one that's actually fully updated. I think I have though, because there are like some typos in the like our first draft of this PowerPoint, so I had to fix those. But anyways, yeah, I posted the file and announcements if you want to go and look at like the previous slides. You're welcome. So anyways, so then we have a person Gerard equals Joe. You guys already said it, it's a copy constructor. Now, how do you guys know that's a copy constructor? Like, how do you guys know it's one? There's like a way you can always know whether it's a copy constructor or a copy assignment operator. Because an object is being constructed. I mean, that's a little bit of common sense genius, but anyways. I'm just joking with you, by the way, Stephen. Love you, bro. But anyways, because Gerald wasn't made yet. Yeah. So Gerald, like, okay, basically, Yeah, Gerald was born on this day, and he was born equal to Joe. But anyways, no, okay, like the easiest way to like look at it is like, does it have a type? Does it have like a class like next to it? Like you can see like it has the person object next to it. So like that's how you can just like tell. Now, finally, we have like you can see what about line 14? What's happening there? Where it says Ricky equals Joe. Copy assignment operator. Cool. Copy. Because obviously you can see we made Ricky beforehand and then we set him equal to Joe. I guess Ricky was just equal to Joe, man. With a different name. So yeah, that's that. Yeah, number 9 or line 9 was copy constructor. So yeah. So yes.
But it's not a shallow copy or a deep copy, or can you tell from just that?
To look at shallow versus deep, you really have to look at that's dependent on dynamic memory. So it's like, I'm pretty sure these are all shallow copies because I didn't use any dynamic memory when making the classes. Or actually, I take that back. So like, yeah, there's no dynamic memory. So it's all shallow, but like a deep copy is when you take into account the dynamic memory and like actually use it basically. So
that set Joe, Gerard, and Ricky all to the same basically address, like you change one, you change the others, or is that just?
So like, wait, say that again, sorry.
Wait, so if hypothetically, if they were deep copies, would that mean when you set one to the other, they're all like connected to each other, or like
the difference between a shallow copy and a deep copy isn't like what they do. They do the same thing. It's just the fact that with a deep copy, you have to account for more things. Like they're still doing the same function, which is, you know, setting values equal to another. But it's more like with a shallow copy, if you don't have any dynamic memory, you can just set the values straight up equal to each other. But if you have dynamic memory, then if you think about it, if you have a shallow copy and you have dynamic memory, right? You set the values equal to each other. Well, they have the same spot on the heap, right? So what that means is that if you go into like the first object that you just copied and you deallocate those spots on the heap, then you're also deallocating that memory for the new object that you made. Now that's an issue because that means when you basically delete one or the other, aka if one or the other falls out of scope and the destructor is called, then one's going to be deleted, one's not. And then when you go to try to access the one that wasn't deleted, they still need, you're going to have issues. So that's why you make a deep copy. Is basically what a deep copy is really doing is making separate locations for that dynamically allocated memory in each object, so that you know, like if you delete one object, you're not also deleting the other. Does that make sense? Yeah. Okay, cool.
Wait, one more question.
Yeah.
Okay, references can they be used from memory on the they can't, right?
No, I don't think you can, like in order to
Downfall of them, right?
yeah, like in order to point,
or vectors or anything like that.
yeah, in order to point to something on the heap, like because the heap is literally like a memory storage location basically, like you need to use pointers, to my knowledge. I mean, I could be wrong. If I'm wrong there, somebody correct me in the chat, but I'm pretty sure. Yeah, you'll always use a pointer when using dynamic memory for the most part. Yeah. So once again, this is these are some examples. I remember like all the way back in the midterm review, like I like coded the for the copy assignment operator, like I coded it myself and I didn't even think about it. I did it like real quick and like I actually had a mistake, but don't worry guys, this time around it's fixed. But anyway, so this is like how you would make a copy assignment operator. You can see that it uses the operator equals, which we'll talk about later. That's part of operator overloading, which we have slides on in the future, near future. And then in the bottom, we have the copy assignment operator where you can see, and you can notice that the parameter for both of these is basically a const. Why do we want const? Well, that's because we don't want to change the object that we're copying. And then you have a reference to that object. So, you know, hopefully this kind of makes sense. And also you can refer to Fox's slides if you need to like see this in more detail.
Wait.
Yeah.
The top one is copy assignment operator and the bottom one is copy.
Yes. Yeah. So like you can see, like you can tell that the top one is a copy assignment because it has the operator equals, whereas the bottom one is just like person. It's literally just a constructor with a like the copy constructor is like not really anything special. It's just a constructor where you pass in another object for the parameter. All right, so then we have code organization and compilation. This is like stuff from like all the way back at the very beginning of the year that I'm sure a lot of you probably have forgotten. And like, I honestly had like forgotten some of this as well because we just haven't looked at it in so long. But here we are reviewing it anyways because we need to. So source files, they're going to be what you like if you're like in your C-Line or Visual Studio or whatever, they're going to be your .cpp files. And that's definitions. Now, what's a definition? A definition is basically like what actually is happening. Like you define what's going to, what function is going to be performed when you call something. Header files use .h, and that's going to be declarations. Like I have written right there, it's basically saying to the compiler, yo, I exist, I'm a thing, like don't ignore me. Yeah, prototypes, Jonathan said in the chat, that's also a good vocab term to know. It might be used on the exam, so thanks, Johnny, for that. But yeah, basically like you have the declarations. It's not actually saying what they do. It's just saying I exist, don't ignore me. Now, what's the point of declarations? It's so that you can declare everything at the top. Now, keep in mind, C++, the way it runs is it's going to run basically from top to bottom. So if you declare something and then you try to use a function, if you actually define something and you try to use a function within that function that is not declared yet, that the compiler has no clue exists, then you're going to end up getting an error. Whereas if you basically define everything, or if you declare everything at the top real quick and then do all your definitions, then it'll bypass that issue. Translation unit is a prototype. No. So a translation unit, which I'll get to, this is like the standard, like you can go to any website and this is basically the definition it'll give you. Like go to Wikipedia, go to like some tech tutorial online. It says, quote unquote, a basic unit of compilation that includes the contents of the source file plus header files included in it. So basically what a translation unit is, it's a very, very beginning when you're starting a program, when you're going to run it. It's basically looking at what the program like has, and then also like anything that is going to be connected to that program. So you can think about like the translation units as like basically like the preprocessor directive, like which actually I've written right there, I see. But basically what that is like, just think about it like the translation units are happening when you have the very, very, very beginning of the program with like all your include statements and stuff. That's what the preprocessor directive is. It's like that spot where you have like hashtag include, using namespace, stuff like that. Then we have the 3 steps. I don't think you're going to have to know this 3 steps like super in depth, guys, but I think there's a good chance you'll need to know at least the order that they have. So there's pre-processing, which is basically, making sure that it's once again looking at those translation units and like taking them all in at the very beginning, and maybe you have like a pragma statement or something. Then there's compiling, which is making sure that the compiler is making sure your code actually makes sense, like it makes syntactic sense. And then there's linking, which is basically the end process where it's looking at all the extra files that you're going to be like including and everything and making sure that they can, actually be linked to the program properly. Does that kind of make sense to you guys? Like, hopefully, yeah. Yes.
Okay, the stuff in a header file, would you consider that a prototype?
In a header file?
Yeah.
Yes. Like those are like basically all going to be prototypes, basically like.
Okay. Well,
Whereas in the source file, it'll be definitions.
yeah. Well, I just think of like prototypes as like at the top of like your main function. But okay.
Yeah, like you basically at the end of the day, a prototype is just a function that you like say exists, but like it doesn't actually do anything yet.
Okay.
Yeah.
Not the definition.
Yeah. Yeah. Prototype, as the other Chris said, prototype is just a declaration, basically. Yeah. I think for all intents and purposes for this exam, you can just use them as synonyms and you'll be fine. So then we have command line compiling. By the way, guys, just a heads up for like time-wise. I don't know how long it's been. Okay, it's 8:34. So it's been about 30 minutes. We're about halfway done with the slides. And I'll try to go a little bit quicker so like it doesn't take too long. Not everyone, okay, so command line compiling. Okay, let's be real, guys. You put like a fancy program into your system and you can run it because you have C-Line or Visual Studio Code, but let's say you want to run it on a different computer that doesn't have these and all it has is like maybe a compiler that you install real quick. This is why you would use command line compiling, or maybe you have a Linux system that you just want to run something on real quick. You don't want to have to install, Visual Studio or something. Okay, you use command line compiling where you basically just do it with, commands. That's basically what it is. You can use a makefile. Shane, were you going to say something or are you just stretching? Okay, just making sure. All right. So now when you want to run a command to run a program, it's kind of annoying actually. It looks really complicated. There's a lot of things to memorize. So that's why we have makefiles, which basically is you run the command once, and then later on when you go to run it, depending on what you have, you might have to include Ming W32 dash in front of it, but basically you're just writing make after you've have everything made. So that's why we make a makefile now. I know that some of you are going to ask in a second, okay, what do you write in a makefile? Do not worry, we have something in the next slide where I show an example of a makefile. So don't worry about that. I will show you exactly that in just a second. But then there's also command line arguments, which are like basically you can add more like, I don't want to use lines because they're not lines. It's more like you just like add a space and like you just put in another word. But basically you can have command line arguments where you basically have maybe when running the command, you want to include like some text that can be used or something. That's what you would use the command line arguments for. And that goes into basically an array of arguments that maybe you can add functionality to your program with. Now, when you go into a program and you do like args of 0 in C++, this goes into another question that was on the practice exam. That's actually the program name. And then args of 1 is like your first argument. So, and I don't know if you guys remember all the way back from 3502 when we were in Java, but we actually did quite a few labs with command line arguments. I think like was like Calce one of those, or I have no clue, but I know that we did. I know that we definitely did labs. So if you had issues with like understanding this, you could go check out your old labs from that, and that might help you like explain it to yourself. All right, so then we have an example of the makefile. Like I said, I wanted to show you. G++, that's the, or actually let me go up. So you see build, that's like the command name, like that doesn't actually really matter. You just have to have it there with that colon, and then you go down and you need to make sure that you tab. It's not 3 spaces. It's not like a space. You need to tab. Okay, so keep that in mind, guys. Then you have the next argument there, which is basically saying use the standard C++11. You don't have to have this in a makefile. That's just basically making sure that you're using the proper version, so that maybe if you're giving this to somebody else, they don't have issues running it because they know that they have this standard. You're gonna have -O to say that's the output, and then you're gonna have the program name, and then you're gonna have the files that you want to be included when you run this program in the makefile, and you only include the source files. You don't have to include the header files in the makefile like code. So this is just an example of a makefile. A makefile is like, it's not super complicated, so don't overthink it. Just like do this if you ever need to make a makefile. External libraries. So external libraries, they're super duper useful, guys, because it's basically taking somebody else's code and like using it as your own. What is that copywriting? I mean, not really. They do put it on the internet for like a reason. So I don't think it's copywriting. It's just kind of using other people's. Once again, I know Fox says this really often. He's always like, why would you reinvent the wheel if it's already invented? Like, that's basically what you're doing here with an external library. Like, why would we really want to like, you know, hard code like how to make a window object when, you know, somebody's probably already done that before. It's like, you know, when we're coding games or animations or something, you know, that stuff is kind of intense if you look at the raw code, and we don't really want to do that. So maybe perhaps you could use SFML, which is a library, to, you know, create some form of graphical game. You know, yeah, perhaps we've done that before in the class. So that's basically the basic gist of libraries though. I don't think like you're ever going to really like be tested on anything about like specific library stuff. Maybe there could be some SFML stuff, but I highly doubt it. Just like know what a library does, and know like it can be a real pain to like actually install certain libraries and stuff, but all libraries are different. And like learning a certain library is like, you know, basically learning a new system every library you use. So yeah. Also for libraries, one thing, like read documentation, like future stuff. If you're using a library, like make sure to read the documentation for the library like extensively before you try using it, because, you know, like they say like 5 minutes of reading documentation can save you probably like 6 hours of like troubleshooting stuff. So yeah. All right, so now we have normal file IO, and later we'll get into binary file IO. So we're going to use fstream, offstream, fstream, whatever you want to call it. Fstream is basically what you can include to get everything. So when you go to your include statements, I always say just use fstream because then it makes it not complicated. If stream is your input. What does input actually mean though? It means that you're reading data from a file. It means you're taking data in, and it uses that operator right there. You can see it's like to the right or whatever. And then you have your offstream, which is an output. It means that you're writing data out to a file or to a file, output out, and you can see it's using like the little left arrows there. One of those is the insertion, one of those is the extraction. I don't hope that you'll need to know the exact like which one's which on the exam, but yeah, if you do, just like Google it real quick before the exam, guys. Fstream, it'll contain, like I said, it contains both. Not just going to reread the slide. Hold up, I already said that. So if you want to, and then also for using the if stream, right? For using the input, like you don't want to always just always just get like one object at a time and stop at a space. A lot of times you want to get an entire line. So using the getLine function makes a lot more sense. So you can see right there the syntax for the getLine function. You basically do getLine, and then you have some if stream object, and then you have like some string that you're going to be storing the line in. And then there you can also add on a third parameter if you want, which it would be a character for a delimiter. You guys remember what a delimiter is? Like what's like probably the most common delimiter? They said comma. Yeah, comma, semicolon. Yeah, those are all like pretty common. Logan said @ symbol. I don't know if I've ever seen that one, to be honest, but like it could be used. What can be used as a delimiter? Do you guys remember? Anything. Yeah, anything can be a delimiter. So like I think like we had it like on a quiz or something at one point, right? Like it was like select all that apply, and it was like what can be used as a delimiter, and everybody in their heads is thinking, there's no way it can be all of them. There must be one that's wrong, and then it's all of them, and it's like, oh my goodness, you have got to be kidding me. But yeah, that's just how it is. Basically everything can be used as a delimiter. And I also just wanted to add like one quick reminder: if you're forgetting normal file IO basics, you can review file IO with your lab 4 that you did ages ago. That's like the lab where basically we learned how to do this. We'll talk about binary file IO next, and binary file IO, I believe we did in lab 5. So once again, if this is something that you don't totally understand, go look at your previous labs, and I think they'll help you out. Yes.
Okay, weird question. There's a limiter. Could you use like a word or something?
I think it has to be one character. So like, yeah, a delimiter, like the parameter is a character. Eli, you want to like Google that for me real quick to make sure? Yeah. One or more.
So you could do like
Anybody?
a word stop, another word stop, another stop.
All right. So I guess a delimiter can be just anything, like even a word. There you go.
I think the limiter has to be character.
I feel like every time I've used a delimiter, it's been just like a character, but like
Yeah, well,
I've never like,
anything that's
yeah, I don't
not
think you'll
character.
see anything. I don't think you'll see anything on an exam or anything that's not a character. Say it again.
I think like in the C++ documentation for the inline function, it says that the delimiter has to be character.
Elijah tested.
So I think I remember-
Yeah, Elijah, pull up your C line right now, bro. Test this real quick. Try using like a string for it or something.
Yeah, I use double quotes and I use a character, but I had double quotes and it said like the type was wrong. So use double quotes.
Yeah, so like that's what I was thinking. For you guys on the Zoom who can't hear, what Akshay is saying right now, and I think I had the same experiences. If you try using a string as a delimiter and like not a character, I'm pretty sure you get an error. Get line requires char type. That's what Brian says. Yeah, so I think like maybe in other languages you might be able to use more than just like one character, but I think in C++, in our IO with like if stream and f stream and all that, like I think it, or rather just the getLine function in general, I think it does just have to be a character. So no strings or anything. Yeah. Hopefully that makes, did you guys in the Zoom, like, do you guys know what I was saying? Like the question I was answering, or no? If you guys need to like re-explain, I can re-explain it real quick. Nobody's saying anything, so I'll just move on. But once again, if you guys have any questions, let me know. So we have binary file IO. Oh, Jerry asked me to re-explain. Okay, so here, this was the question. The question was, can you use a like string or like something with multiple characters as a delimiter? Now, we just tested it in C++. Basically, the getLine function is going to force you to put in a character for that parameter. So in C++, you can't. However, there might be, other languages or even other like types of IO or with other functions or something where you can. Does that make sense, guys? Hopefully. Okay, cool. Yeah. Okay, so then we have binary file IO. It's really similar to normal IO, but if you try opening a file that's written in binary, you're going to look at it and think, what the heck is this? Because you're not going to know what it says at all. Basically, normally when you're like declaring some form of if stream or off stream or whatever, you would have the file name and that's it. But if you're doing binary file IO, you got to add another parameter where you have this iOS based binary to say that you're reading and writing in binary. And then you're going to use the read and the write functions. Now the read and the write functions are going to have two parameters. Okay, guys. So the first parameter in the read or the write function would be a char pointer, car, however you want to pronounce that. But now, if you really think about it, what is a char pointer? Char pointer? What really is that? String. Yeah, there you go. Yeah, I mean, it says it in the PowerPoint, but because think about this, guys. So you can have like a character pointer, and what do you usually have when you have something pointing to something, like in its declaration, especially if it's on like, yeah, it's usually an array. And so now think about it for a second, real quick. If you have an array of characters, like what is that? A string, yeah. I didn't include it, but make sure that you know like the end of like a string for the character wise. It's like \0, right? Yeah, something like that. Yeah. Anybody remember like the exact name of that? I know that there's like an actual name for that. Null terminator. Yeah, there you go. So the null terminator is like the \0, which like denotes the end of the string, just so you guys know. And then you have the size of function. Now the size of function does, it basically looks at whatever you put into it. It looks at its data type and it finds the number of bytes in that data type. So like I have written right there, like an int is 4 bytes. So what is this useful for? Let's say that you know that like in a binary file IO sense, you know that like you're going to have an int that you're going to read first. You can just do like size of int or size of that variable that you're putting in or whatever, and it'll know to read 4 bytes. It's very, very commonly used. And I think there's like also, once again, there's size of in the practice exam, like they do like size of like some int or something. And you have to know that that means 4, which once again, we can go over that when we're going over the practice exam, guys. Peaking at 77 people in the Zoom right now. It's crazy. But anyways, so you have one class. Okay, inheritance. Cool. Why am I reading the slides? See, the slides are like a visual element for you guys. It's not what I should be reading. I should be talking about the slides. Anyway, so now we have inheritance. Oh, Stephen, hold up. Stephen said something. No, but like instead of char pointer x equals hello, shouldn't it be char pointer x like brackets? This is like so confusing to read to the people in person here, like the question, because of the formatting. So like, I'm looking at the, it's like a mini debate going on between like, like what is going on in chat? Okay, I'm just not gonna pay attention to the chat. You guys can like talk about that. Okay, I won't interrupt your conversation. But anyways, so we have inheritance here. So let's say basically you have like one class, right? And then you have another class, and those classes have similar variables. They're objects that are similar. For example, maybe, Chris, I'm actually confused. Help me out here, Stephen. Let me look at your question, bro. Okay, where does it like start this huge conversation? Wouldn't a char pointer array be a string? Yes, a char pointer array is indeed a string. No, but like instead of char star x equals hello, shouldn't it be char star x brackets equals hello. Char star x brackets is a pointer to another pointer, says Brian. Okay, as far as like your actual confusion, Stephen, like I don't want to like spend the entire Zoom call on this question, but if you want, like me and you can like talk about it in like Discord DMs and like figure it out together, okay? Is that fine? Okay, cool. Yeah, because I just want to move on so like the presentation does not take too long. So yeah, basically inheritance. So like let's say we have one object, we have a class, we have a type of, well, it's a type of object, and we have another type of object, and they're similar in some way. For example, let's say we have a person, but then if you have people, you might have different types of people. Like, you know, you might have like teachers, or you might have CS majors, or, you know, stuff like that. So, you know, like with a person, right? You know, and a CS major, let's compare the two, okay? Like with a person and a CS major, you know, they both have a height. They both have, you know, an eye color. They both have all that. They both have all that stuff, right? But, you know, with a CS major, you might have what classes they've taken in their major, and that might be like a different, you know, a different part of the object. Imagine having an eye color. I know that's crazy, but you know, stuff like that. Basically, you could make a CS major, you know, a child class of a person. CS majors don't have relationships. You're not wrong. Yeah, I was gonna say like you could have like a bool or something for CS majors, and like it could be like a Boolean value, like has showered, like always false, bro. Something like that. CS majors, so disgusting, bro. For real. Anyways, heads up, I'm not a CS major, guys. Yeah. So anyways, we have public and private. So inheritance, we have two types. We have the public and private inheritance. Private inheritance is that has a relationship, but realistically, don't even pay attention to private because it's almost never used. You can literally just do a thing called containment. Basically, what you can do is you can have a class, and then in that class, you just have an object. Like you might have a variable that is an object of another class. It's much easier to comprehend, in my opinion, much easier to do. And honestly, people can tell what it's doing more when they're looking at your code if you just use containment. So know that private exists in case we get a question that's like, what is private inheritance? But I highly doubt we will, and you don't really need to know that. Public inheritance, on the other hand, is an ISA relationship, and inheritance goes, public inheritance goes directly with polymorphism, which we'll get to in a second. But basically, once again, if we had a, you know, we have a CS major is a person, that could be a public inheritance, where a person is above, they're the parent class, and a CS major is below, they're a child class. And then maybe within a CS major, I don't know, you have like CS majors who are like, I don't know, you have a junior CS major and like a sophomore CS major or something like that. I don't know, you could keep going down the line. Or you could say that junior, senior, sophomore, it's like above that. Like it depends what you want to do. So cool. Also, if you guys want, like, we can like maybe perhaps look at some like inheritance examples like later, like in the actual code. So we have polymorphism, which sounds really complicated, but it actually is pretty complicated until you actually realize what it is. Chris, that makes no sense. Of course it's complicated until you realize what it is. Like, yeah, you're not wrong. Basically what polymorphism really is saying we're going to have one function, guys, one function name that we're going to call, but basically depending on the data type, we're going to do something different with this function. So maybe like you have, once again, you have a person and you have a CS major, right? And once again, a CS major is taking classes, they're in school. A person, they might not necessarily be in school. So maybe a CS major has a variable for what school they go to, and a person in general doesn't, okay? Now, let's say you wanted to print out all the data of a person. You know, you print out the stuff that all people have, you print out their height, print out their eye color, stuff like that. But let's say you wanted to print out all the data about a CS major, and you wanted to include what school they're going to. Well, then you would need a different function. But would it really make sense to, you know, make an entirely new function name when you're still just printing out data? Like it's the same thing? Not really. You probably are just want to have the same function. That way, also, let's say you have like multiple like people, but then you have different types of people. You can, and let's say you're like looping through like a vector of those people or something. You can just use one function and everything works. So that's why polymorphism exists, guys. It's basically so you can use the same function, but do different things. Make sense to everyone? Like kind of like on a basic level. Anybody who's like, maybe I had no clue what polymorphism was before this, they kind of understand the explanation, hopefully. Yeah. So then we have, I've written here, we have, what's a virtual function? Okay, a virtual function is basically saying, we're going to allow this function to exist, or rather be redefined in a child class. So a virtual function, you might make it in a base class, but then once again, by saying that it's virtual, it says, okay, but allow children classes to redefine this function. I was doing some testing earlier. It does depend on the language and everything. Like, do you need to have the virtual keyword? There are some scenarios where you don't have to have them, depending on language stuff and all that. But for all intents and purposes, just for this class, know that first of all, there can be issues if you don't include virtual and try to make like a polymorphed function. There can be issues. And so just like always have the virtual function if you're going to use polymorphism, probably for this class. Hopefully that makes sense, guys. So then we have upcasting and downcasting. Now you'll see I have good and causes issues there. Upcasting, okay, basically let's say you had like a person and you set it equal to an object that's actually a CS major. Okay, well that's fine because we have all the data we need from the CS major, and basically all the extra data will just like go into nowhere. Like that's something that we can do. But if we downcast, right? Let's say we set a CS major equal to a person. Well, that's an issue because the person might not have all the data that the CS major has. And so now we're going to have data that we just have like awkwardly uninitialized that's going to cause errors. So that's why upcasting is good and downcasting is bad. Now you'll see at the bottom, basically I'm talking about how pointers can be made, and you can make, you can have like a parent class, you know, use a base case. Downcasting is from child to parent. So yeah, downcasting would basically be setting a child equal to a parent, if that makes sense. So you're setting something lower equal to something higher. Let's see, Brian, if you're looking at certain slides, I think Resh actually mentioned like this was like in some of the slides that were on Canvas, they were like, it was actually messed up. But once again, downcasting can cause issues. I mean, you can like look at this up and find like a tech Wikipedia type thing. Basically, yeah. Here, I can show you guys. Let's see if I can share real quick. I can check for you guys. Just to make sure. So yeah, did I explain this wrong even though I read it correct? Let's see. Just got a Discord message. But anyways, let's see. Maybe let me check. Upcasting is good, downcasting bad. Yeah, so the PowerPoint says it correct. Once again, so upcasting, which is good, is going to be when, like I said, so you're taking an object that has, what is Brian saying? Upcasting without dynamically allocating memory can cause data loss, but it won't throw an error. Yeah, so my original explanation was good. Basically, once again, when you're upcasting, you're taking an object that has extra data, you know, like the parent class or the child class, or rather you're taking a parent class and you're setting it equal to a child class so that that extra data is just being thrown out. That makes sense, guys? Whereas downcasting, you might have no initialization for certain parts of an object. Sorry, that's like such a choppy definition, but like it's just hard to word. But anyways, is there still any confusion about that in chat or no? Not seeing anything. Where did my mouse go? That's a good question. My mouse has like suddenly disappeared. Okay, well I can still go on the presentation, so I'm not going to question. I have no clue where my mouse went. Data structures. Okay.
Wait,
Yeah.
Upcasting is a parent to a child?
So like, okay, how it works, think about it like this, right? Just upcasting is good. If upcasting is good, what that means is
I
that,
would think that like taking a child and like, I don't know, using it as a parent quest, is a parent quest such a quest?
so like upcasting, you have, just think about this. Upcasting, which is good, you have more information being set to less information, and then the extra information,
Sending a child has to be parent quest,
yeah.
yeah? Right?
Yeah, so like,
Upcasting from child to parent or parent to child?
okay, I think the confusion here is like, it's like, depending how you word it, like, it can be either or, like,
Oh, come on.
but like, just know that once again, know that what you're doing, because like, I could say like, you're setting this to this, and then it could be, and like, I could say you're setting A to B, but that could be interpreted as setting B to A. So
Okay, so let's say
instead of,
parent X is equal to you child.
right, so if you have
Is that
parent
upcasting?
equals to child, so that means that you're taking all of the data from the child, which has more data, and setting equal to the parent, so that would be upcasting.
Okay.
That makes sense? Okay, yeah, Akshay brought up a good explanation for this. If you have parent equals child, guys, then that means you're upcasting because the extra data is being thrown out. But if you have child equals parent, that means you're downcasting, which is what causes the issues. That makes sense? That's actually a good explanation, finally, like with like actually definitive wording. Okay, cool. Yeah. I call that Alabama. Good job, Johnny. Funny joke. Okay. Anyways, so now we have array. We have some basic data structures. Obviously, when you take data structures, banjo noises. Yes, Camilla. Then we have data structures. So I want to get to this. Let's see. Arrays, fixed length, and arrays are contiguous memory. They're like basically the only thing that's contiguous memory. What that means is that when you have something in an array, like it's just like all directly in line and it's just kind of all there. Then we have vectors, they're variable length and they're non-contiguous. Like I said, basically everything but arrays is non-contiguous. Linked lists, I'm sure you guys know a thing or two about linked lists. I mean, obviously we do linked lists as project one, but it's basically where you have a node, which is a node is basically an object that points to another object in that line. Aren't vectors contiguous? No. I mean, they're not in memory. No. Basically, once again, in actual dynamic memory, like everything like but an array is like non-contiguous. I think. Awkward moment when like somebody walks in the room right now, but they should be. I'll check that out later. I was under the impression, because I remember like in one PowerPoint, it says like basically everything but an array is non-contiguous, but I'll like check that out later and like edit it if I need to, and I'll post an announcement in the Discord. But yeah, I'll like check the PowerPoints and stuff. Linked lists though, basically you're just gonna have a ton of pointers. And in those pointers, you're going to have like a, you might have a header tail, you're gonna have nodes. C++. Okay, yeah, I'll edit that in the PowerPoint then, guys, and I'll make sure to post the updated afterwards. I am trying to think about where was that like it said that everything but arrays is like non-contiguous, but I'll fix that, don't worry. Linked lists, you're just going to use pointers to get to everything. You have the nodes. In those nodes, you have a header, a tail, which is basically the beginning and the end. The head, the previous object would be set to null pointer, and then the tail, the next object would be set to null pointer. And then in the map, those are going to be unordered under the maps PowerPoint. Okay, cool. I'll check that out. Once again, yeah, I'll edit that. DM, can you explain later about the linked list? Yeah, I can. Yeah, sure, I can explain that. You're saying from the midterm. Okay, yeah, okay, yeah, I can try to, I can DM you and like explain them like a midterm question, that's fine. Sorry, just people in real life, there's like lots of questions happening right now. But anyways, maps. So yeah, maps are going to be unordered. Now you use a key in a map, and ideally this is a primary key. If you've never heard of the word primary key, it's actually a database concept. If you ever do like SQL or something, you'll use primary keys a ton. But basically what a primary key is supposed to be is it's supposed to be something completely unique. So like your social security number would be basically the government's primary key for you. Your name is not really unique, even if you use your first and last name, like somebody else could have the same name. So yeah, that's like why we're assigned SSNs. I mean, you could say like maybe your UFID is unique as well, stuff like that. And then we have a stack. Stack would be first in, last out. Basically what that's going to have is, so we're going to have in the stack, so think about it like you're stacking like books on top of each other. So what that means is if you put one book on the other, like in order to get to the book below it, like you have to, take off the book that you put on top. See that? And, make sure it's first and last out. And then for queue, I think I made this explanation or this comparison once before. Queue is basically like, think about a music queue. Like if you're like, I don't know, back before like Discord or not Discord, back before YouTube destroyed music bots in Discord. If you have like a queue of music, like you have a ton of people listening to music together, you put in a song, and then after that like song is played first, like it's going to go out. So it's like first in, first out. That makes sense, guys? Yeah, cool.
What's a multi-map?
That's a good question. I've never seen multi-maps before, and I don't have anything in this presentation. If you want, I can like research that with you later. I saw that was in the study guide, and I was like, I don't think this has ever once been mentioned in the class. So yeah, well, I know that it's a thing because if you Google it, it is a thing. I Googled it. I Googled it and it's definitely a thing, but yeah, I didn't see it anywhere in the actual course content. So like, if you want me to like research real quick, like what a multi-map is and like post some stuff on it, like I can. I'm assuming that we probably won't need to know multi-maps in depth as to what they actually are on the exam. So yeah, then we have a stack and a queue. Now, as for multi-maps, once again, like I said, they're a thing. If I were to guess, they'll probably be in data structures when you take that class. Just Brian said it's like multi-sets, but with maps, I guess. That's what he said. Okay, cool. Then we have operator overloading. I think I alluded to this earlier. So if you want to compare two objects, but let's say, okay, like you have like two ints, it's like obvious what the comparison is going to do. Like 5 is less than 7 that I have written there, like, okay, cool. But let's say I decided to add in like a Pokemon reference, right? So those are two Pokemon names, you got Shuckle and Pikachu, right? Let's say I wanted to see if one was like stronger, or that's basically greater than the other. How would we just check that? Like that wouldn't really make sense. Like we can't just compare like one thing and say that one Pokemon is stronger than another. Like maybe like you have like some Pokemon that have like certain types and they're like, okay, correct me if I'm wrong. I haven't played that much Pokemon, but like if you have like a fire Pokemon going against like a Pokemon that's like, I don't know, like a leaf Pokemon or something, like it's probably like really strong against it, right? Something like that. So like, yeah. So like, you're going to have to check more things. Bro said leaf. Like, I don't know. What's the like plant? Grass? Okay. Something like that. Yeah. I don't know. Like, I don't know the exact Pokemon names, guys. Chill. The weed Pokemon. But anyways, like my point here is like, you're going to have to check a lot more than just like one number, right? So that's like the whole point of operator overloading is basically you're looking at objects and, you're looking at the objects and comparing them based on different things. So like is something weak against something, maybe you have like a million, or maybe you just have like a value that has 3 values and you want to add the 3 values and then compare them or something. That's why you would overload an operator. And you can do this with like less than, you can do this with like the double equals to see if they're equal. You can do this with just about anything. Now you use the operator keyword and you can see right there, I have it written as an example. That's how it would look for a function like this. And also, you might want to like put in, there might be a parameter to put in there, maybe a reference to another variable. And then also like usually these would be like void for the data type, just so you guys know. You're not really returning anything. Well, actually I take that back. You could be returning like a bool or something. So yeah, just keep that in mind, guys. Hopefully that all makes sense. I think like if I were to guess how they would do this on the exams, they'd probably give us a code snippet and like they'd like redefine like a less than to be something specific, and we'd have to like look at it and like figure it out, just so you guys know. Then we have function pointers. All right, guys, let me keep it a bean with you guys like real quick. Like function pointers, new stuff. Like I barely know this stuff too, so like we're kind of learning it together. But anyways, here's my real quick ramble. If I say something wrong, just like shout it out in the chat, okay? So basically, let's say you take a function pointer, or let's say you take a function, but like let's say you wanted to like pass it into like another function, right? Like you can't just like put a function in a function. So what you could do is, that's when I think like the main use of function pointers is like if you're going to put a function as a use in another function. And you can use a function pointer just like a function, but it's obviously like, you can like dereference it and all that stuff, just like a normal pointer. And then you can use it. So that's basically the gist of function pointers. Now, if you notice, I have the syntax written down there. Notice how there's a similarity in the syntax to like just like defining a normal function and how to define a function pointer. Basically, what you're going to do is you're going to take the function name, you're going to put a little asterisk around it to say it's pointer now. You're going to put little parentheses around it. You're going to keep the data type there. And then notice that like in the parameter list, like it doesn't really matter what the parameter names are because you're just pointing to something. So you don't need to put in the parameter names. You just need the data types of the parameters. So does that kind of make sense to you guys? Like how to make a function pointer, how to use it, and kind of what it's used for, hopefully. And I guess like maybe we can try like, yeah, function pointers are indeed whack. I feel like the best way to actually like explain this would probably be to like get examples and like work through them. So I don't know if there were examples in the practice exam or not, but maybe we could try to get some examples after we're done with the presentation. All right, cool. And I think this is the last part of the actual review. What time is it right now? 9:12. So yeah, we're finishing up. We're about an hour in, a little over, and then we'll finish this up. And then I'll just like, obviously I'll be answering questions from the practice exams and just explaining them to you guys conceptually on the whiteboard. So like basically past that, if you guys want, you can leave or you could stay. It really doesn't matter. So yeah, let me real quick explain the templates. So, I actually find it funny. I was talking to a friend of mine at UCF right now, and they were like working on like a lab or something where they had to do like something really similar to the lab we did back when we were doing stacks and queues. Now, if you guys remember, when we were doing stacks and queues, that lab, we had to use a template. And what a template really is just a placeholder for a data type, because you're basically saying, I don't know what data type I'm going to use, but the functionality is going to be the same no matter what data type. So let me just put in something else real quick, and you can figure out the data type later. So that makes sense. So yeah, but I was talking to somebody like, and they showed me, they were like, oh, look at this. It's pretty cool. I can make a stack and a queue now. And I looked at it, and the first thing I said was, yeah, but why aren't you using a template? Like you realize that if I use a stack and a queue right now with your current code, like I have to use an int, which is like a slight issue. Like what if I wanted to make a queue of strings right now or something? Then it wouldn't work. So that's the point of a template, is basically, let's say you have something like you have like a vector class or something that can be used with basically any data type that's like, it's really the same, even if it's technically a different data type. You don't want to rewrite the code for every data type. And that's when you're going to use a template. So in order to use a template, you're going to go to the class or whatever you're going to use it in, and you're going to type the syntax right here. You can see it says template, and then you got the like little like less than sign and then like greater than sign at the end. And you have the type name, and then you have like the big uppercase T, which is really commonly used, but that can actually be like anything, like any name works. When is it better to use template instead of auto data type? Auto is like usually like when you're like making something like when you're declaring a variable. It's not really when you're like doing like object oriented programming. Like this is more for like if you're making like a class or something, Johnny. Whereas auto is for variables. Like for example, when I was making the map iterator earlier, like if you don't want to write out map iterator, that's just one variable right there that's on the stack. Whereas this is if you're like making some form of class and you want to use this. Does that make sense, Johnny? Yeah, okay, cool. So yeah, that's how that works. So yeah, then we have that syntax right there. Once again, just think of a template as a placeholder data type, so we don't have to actually know what data type we're doing if we're doing the same stuff anyways. There you go. I think that's basically the end of the PowerPoint, guys. So let me, once again, for this few things that I will change, I'm going to change a few of the things in the PowerPoint and I'll post the final PowerPoint, like some of the exact wordings. I'm going to try to add the example that Akshay pointed out earlier for like the parent and child stuff to make it more like easier to understand and like the less misinterpretations basically. And then also change like, what was it? Where I know there was something I had to change. Somebody remind me on Discord or something. But I'll make sure to change those things and like re-upload the PowerPoint. That's why I was like holding off to upload the PowerPoint originally, was because I wanted to just post the final later. But because I knew like, obviously there might need to be edits and stuff. But yeah, I'll upload like the actual updated later. But anyway, so you guys I'll switch to the camera that's pointing at the whiteboard now. And we can just start going over like practice problems. And yeah, thanks guys. If you want to leave, like you feel free to. If you want to stay, like feel free to. Doitashimashite, Jonathan. Of course, Danielle, and peace, guys. I'm going to, let's see, switch camera. You guys don't have to be like looking up, like, I don't know, looking up my nose or something right now. I have no clue what this camera is showing. Arigato, that's Japanese for like thank you. Nose. Let's see. Okay, can you guys see the whiteboard now? Let me see if I can stop streaming. How do I stop streaming my screen, bro? Let's see. How do I do this? Hold on. All right. Should I end the recording, or do you guys want me to keep the recording going to like see questions explained later? What do you guys prefer?
Just keep it recording. Why not?
Keep it going? Okay, cool. Okay. How do I like, I'm trying to figure out how I can stop sharing the screen so you guys can just see the whiteboard. Let's see. Oh yeah, I'll keep recording. Oh wait, I can stop the share. Okay, so now you guys can just see the whiteboard, right? So are there like specific numbers of questions that you guys want to go over on the practice exam? Is this going to be posted online? Like I'm planning, I'll probably like upload this unlisted to a YouTube channel or something and then post a link somewhere. That way you guys can refer to it later on, hopefully. The only issue with that is like, I know that like the video is probably going to be massive considering how long it is. So it might take a while, but 3 to 7. Okay, cool. It opens at 3 p.m. Oh, the exam. Oh, what time is, oh yeah. Yeah, the exam opens at 3. I think you have an hour and a half to take it and it closes at 7. So like theoretically guys, right? If you want to have the max time, like start by like 5:30. Exam is cumulative. Yes, you're correct, Milana. I believe it isn't. I mean, once again, look at the study guide. I'm pretty sure just whatever is on the study guide will be on the exam. So yeah. All right, let's move to this. I had a request for number 3 through number 7. Let me pull up the practice problems on my laptop real quick. Say again. So I think so. Like I think for the exam, I'm pretty sure somebody could check this. I think it opens at 3, it closes at 7, and you have an hour and a half. So it's like.
What I meant was like I asking for questions 3 to 7 or verifying the time.
Oh, that was an answer for the time. That was not asking for questions. Oh, you abs. Could you elaborate? Okay. Oh, 15. Okay. Okay. Wait, hold up. Okay. 3 to 7 was time. I thought that was questions 3 to 7 per second. Okay. My bad. Let's see. Could you elaborate on question 15? And also number 11. I'll do 15 first and then 11. I do have notes on all these so that it would aid me in explaining them to you guys. I wrote these down like basically right before this meeting. So as I was looking through them, I can tell you guys right now, the practice exam was pretty hard. Like honestly, like legitimately very hard in my opinion. I did not do very good on it the very first time I took it. I'll tell you right now. But I think that's probably like everyone, to be honest. Let's see, I'm pulling it up on my screen so I can see the questions and then I have my notes here as well. How is about the same?
Are we able to take the practice exam multiple times?
Yeah, it's unlimited attempts, unlimited time.
So stuff.
Where the heck? I'm looking for that. I forgot where it is. It's in module 14, right? Or module 15. Okay, here it is. Final exam practice. Let's see. Oh gosh, this is terrible, guys. I'm glad I'm not streaming my score on this practice exam.
What'd you get?
We don't talk about it.
What'd you get? It's like, oh my god, I got a 91.
No, it's not that. I'll tell you right now. Let's just say my score on this practice exam would be failing the class at first, but we figured it out. It's all good.
What, like a 50 something?
Okay. When I say failing, I mean like not a C minus. There you go. Or not a C. There you go.
So like a 65.
I mean, you'll just have to keep guessing. Hold up. So anyways, let me get to 15 and then I'll do 11. Let's see. Yo, I got 15 wrong originally. Let's go. But no, I figured this one out. So, okay, I don't really want to I don't think there's really much for me to actually explain visually for 15. So let me give you my oral explanation for 15, okay?
Can you like share 15 somewhere?
Okay, 15. No, if you don't have your laptop up and you're not looking at the practice exam right now, 15 is basically, we're not sharing the screen right now. We don't need the score to be out, bro.
Oh my god.
But anyways, okay, 15, what it really is basically it's giving you some code. What? What 15 really is, it basically gives you some variables, right? And then it's asking you how many are dynamically allocated on the heap in a function. I actually explained this kind of earlier, but basically you have a ton of variables and you have one pointer that's pointing to dynamically allocated array. And then you have array values being assigned. Now for this function, the reason it's 0, guys, is because all of the variables that are on that function that are actually there are on the stack. The pointer is pointing to variables that are on the heap, but those variables are not actually within that function. They're just being pointed to. Does that make sense? That's why it's 0 and not 5.
Wait, say that again.
Chris,
Yeah, what's up?
I was actually just wondering if I could ask something about that. Is there an example of a dynamically allocated variable? What would that look like, basically?
Let me think about this for a second.
If that actually is a thing.
I think that definitely is a thing.
But what would it look like? What would I have to look out for to do that?
Let me check that real quick. I want to see if I can find an actual syntactical error answer for that real quick, Brian, if that's fine.
Yeah, I mean, I also got this question wrong, but I thought it was weird because basically the whole point of the question is that all of these variables are on the stack, but by that logic, all everything is on the stack. You don't put variables on the heap. Memory data is stored on the heap, not variables, right, or something. So it seems kind of weird when it uses the word dynamically allocated variables.
Brian, I think an example of that, where it's actually there, you know how you can in a function, let's say you have a main, right? You have an object. Let's say you make your own object, right? Once again, let's just say you make a person class, right? And then you say person something is equal to new person, and it's not a pointer or anything. I think that would be an example.
Person is equal to new person.
You did, let's say you did person Bob equals new person, just on you didn't have
but Bob is just another pointer.
But right?
I'm
pretty sure you can make it so that Bob is not a pointer. You can just say person Bob equals new person, just directly in your main. I don't know if that makes sense to you, but I'm pretty sure. One second, let me write out. I'll write out what I'm trying to do on the board so you can see what I'm saying. I gotta get my numbers. Brian, so I'm pretty sure you can see the board, right? Okay, is this good writing height?
Yeah, I can see that.
Let's say you had like, I'm pretty sure you can literally just write this in a main. If you have like a class, you can write person Bob. Try writing this in a class and tell me if it works or not.
Trying it right now.
Oh, my handwriting's so bad, but try just doing that.
Person equals new person. I'm getting red squigglies under the under the new keyword, and it says no suitable constructor exists from person pointer to person.
So make it a pointer, and does that error just go away?
Let me make it a pointer. Yeah, the squiggly just goes away.
Okay, so like my best guess, once again, I'm pretty sure my reasoning for this question is still solid, of like, it's because it's pointers. They're saying technically it's not there. But like, yes, you're right, Brian, with this logic, like, I don't think there's a scenario I can think of off the top of my head where like it wouldn't be 0. Does that make sense?
Yeah. Yeah.
I
guess
think this wording is kind of slightly goofy, but yeah.
I have a
Like I
somewhat
originally said
related.
5 as well, but it just kind of isn't. So
Can you explain number
15, is that the one I just did?
Yeah.
Okay, basically, my long story short, when you have stuff like dynamically allocated, according to this exam at least, and by the way, the answers on this exam, believe it or not, it's going to use the same logic on our actual exam. So keep that in mind. Basically, when you have something dynamically allocated, because it's a pointer, they don't actually consider that variable to be like if like actually in the function, they consider it to be somewhere else. So the answer was 0.
I have a somewhat related question, like semantic wise. Can you hear me?
Yeah.
Okay, so like, is there a special name for like? I remember this. They were saying in some of the original or like earlier presentations, it was like, oh, so if you don't know how big you want your array to be, you set it to a variable and then get it during the program runtime and then allocate it on the heap. Is there a special name for that, or are you dynamically allocating every single time you use new, even if you like do it with either a definite number of like items in an array or one that's determined at runtime?
Okay. Hold up. I gotta digest that entire question there. So you're
Sorry.
saying, okay, let me go through this slowly. Actually, I'm gonna tell you. Can you repeat the question? Go through kind of slow.
Yeah, sorry. Okay. So let's say you want to make an array, but you don't know how big you want it to be. So you use like pointers. So you like see in like size or whatever, and then you say int array is equal to new int, and then like within the brackets size. Is there a special name for that, or is it called dynamic allocation whenever you do like anything with the heap?
Yeah, so like dynamic memory is anything you're controlling. So like anything with new is technically dynamic. Like basically the big point of dynamic is just you're controlling it, or your program's controlling it. It's not being controlled automatically by the stack. So like,
Okay, so that specific scenario doesn't have a name. It's just like a thing you can do with dynamic memory, but
yeah.
it's not like special.
Yeah.
Okay, cool. Thank you.
Yep. Basically every time you're using new or delete or whatever, you're using dynamic memory, to my understanding at least. Let's see, what other questions besides 15 were there? I think like number 11 was on there. Oh, I can do number 11. That one is not that bad in my opinion. I actually got this one wrong originally too, because I didn't think about like a rounding error originally. And then I realized, I was like, oh dang, that's awkward, but it's okay. Let me pull it up on my screen. All right, so basically the biggest thing with this question, my jacket's stuck in this chair, bro. How does this happen? Okay, the biggest thing with this question is rounding and like looking at parentheses. So, hold on. So you guys can see the whiteboard again, right? So, let's see. So we're gonna have like a value, and what value does it say it is? It's saying the value is 13. So instead of writing value, I'm gonna write 13 for the explanation, so I can see it.
Chris, is your 11 the same as my 11?
It could be a
My-
different 11. Do you have a different value, Brian?
My 11 is the question, will the code compile properly? And it's talking about const and const methods.
Yeah, that's not my 11.
That's my
So
12.
I guess if the numbers, maybe they're mixed up, maybe they aren't in the same order. So what question are you referring to by number 11 actually, for the person who asked? Was it the one with the 13 and like the bit shifting, or was it a different one? Bit shifting? Okay, yeah. I don't know why yours is different, to be honest, Brian. I guess there's like a few, there might be, maybe there's like a few versions of the order.
Did you maybe take it early? Because then they could have like added questions. After
Oh,
the
yeah,
fact.
that could be a possibility.
I
But yeah,
took
you
I
guys said
took
that
the exam yesterday.
the one that you were asking about, they did say was the bitwise. So I'm gonna continue with the bitwise explanation, okay? So anyways, let me go back to it and let's see. So once again, I'm not gonna write val because we see val as 13 and I'm just gonna write as 13 for clarity's sake up here. So basically what we're really doing is we have two sets of parentheses. And we have it like this, okay? We have two parentheses. Can you guys see all this? Just let me know if you can't. And then let's see, what do we have? So now we have right.
It just share your screen.
Well, like the camera's being shared. Anyways. And then after that, we have this. So let's solve this first, and then we can do the second part of the problem, which is where we get to. So what is this, guys? So whenever you're going, whenever you're bit shifting, you're either multiplying or dividing by 2. Now, when you think about this, right? If you have like zeros and ones, right? Like, let's just say you have like a random, can you guys see that at the very top? No?
No, it's cut off.
Hold on. Let me write this lower down then. Can you see right here?
No, it's partially cut off.
I'll write below. Let's see. So you can see right here.
Yeah, that's fine.
Okay. So like, let's say you have like some zeros and ones, right? It's like any number of zeros and ones, whatever. If I like shift this, right, to the right, if I shift everything to the right and then I get rid of this one, does that make it greater or lesser than like whatever it originally was?
Lesser.
Yeah, it's gonna make it lesser because like now this is the ones place, 2, 4, whatever, right? So whenever you have something pointed to the right, it's gonna be making it lesser, and because binary is base 2, it means it's actually dividing by 2. Whereas if you're going to the left, it's gonna do the opposite. It's gonna move everything left and basically add a 0. So it's basically gonna multiply by everything by 2. So hopefully that kind of makes sense as to how that works. Now, we have a val I said earlier is 13. And also what I haven't mentioned is this was initialized as an int, guys. This was not like a float or anything. So anyways, we're gonna do 13 divided by 2. What's 13 divided by 2? Yeah, it's 6, because it's 6.5, right? But like, because it's an int, we can't have a decimal, so it's just 6. Okay, and then we got 6 divided by 2. It's 3, right? And then after that, we're gonna now notice like I had to do that first because it's in the parentheses, right? So then after that, we're gonna go here. And we're gonna go 3. And we're gonna go times 2, times 2, times 2. What's 2 cubed? 8. 8 times 3, 24, right? So that's how you get the first part of that problem. Now, so 2, 4 is gonna be like the first thing that it prints out. You guys see how that works? You guys good? Oh wait, I should check the chat. Hold up. Yep. Okay, cool. Yeah, that makes sense. Okay, good. I'm glad it makes sense. Let me get to the second part of the problem though. So then we have this. So we're gonna have size of, and we have val in parentheses, and we have like an ampersand, and then we have 9. Now, especially whenever you see a singular ampersand, guys, this like automatically should be a red like flag basically saying this is a bitwise operator. Because like if you're doing like a comparison, it's gonna be 2 of them, not 1 of them. Same for if like you have like 1 pipe or something, like that's actually the name for that, believe it or not. It's called a pipe.
Wait, what's up?
This character. This character right here, like the straight line, like if you're doing like or you'd have 2 of them. That's called, this is called a pipe. But anyway, yeah. So whenever you have like 1 of them, you know it's bitwise. So basically what we're gonna do here, remember I talked about the size of earlier, like in the PowerPoint presentation, it's getting the size, the number of bytes of the data type. So what we really could do is instead of writing val here, we could think of this as size of int, yeah. And if you know if you know the int off the top of your head, it's basically actually, well, yeah, it's 4. So this really is 4 and 9. Now when we look at 4, let's write 4 in binary, guys. So we got 0, 0, or I think it back 0, 1, 0, 0, right? 0, 1, 0, 0. And then we have the little n. My hands are so bad. I don't even know how to draw them properly. But anyways, and we got like 1, 0, 0, 1, right? Now, when we have this and here, what do we do? Like, we got to compare them, right? This is a 1, this is a 0. 0 and 1, what's that? What does that evaluate to? With an and. That's a 0. Because with an and, you need both of them to be 1. So yeah, it becomes 0, 0, 0, 0. Now, what is this in like decimal?
0.
0. So then that's why I feel like the final answer to this question, it's 2, 4 from the first part, and there's a 0. The answer is 240. You guys see that?
What?
Like 2, 4 is from the first part, and 0 is from the second part.
Wait, no, wait, hold on. Something isn't right here.
Oh,
I think the confusing part about this question is that the bit shift left operator and the insertion operator use the same symbols. So it's hard to tell what's being used for what.
yeah, are you looking at C out? Like when you're using C out, right? You can see it's printing. You might be confusing the print part of the operator with the bit shifting.
Well, no, because like 4 bit ended with 9
is 0, 0, 0, 0, right?
Yeah,
Which is just 0.
yeah.
So then you print out the first part. Remember, we got 24, right?
Yeah.
Like there's the first part of the problem where it was a val bit shift right 2 and then bit shift left 3. And that evaluated to 24.
Yeah.
And then after that, we're also printing out the 0 from what we just got. So the final answer is 240.
Wait, no, because like no, you have to bit shift. So you take val, all right. You bit shift it to the right 2 times.
Yeah.
You bit shift it to the left 3 times.
Right. And you get 24,
bit
right?
shift it. Yeah, then you bit shift it to the
So
left.
that next bit shift is not a bit shift. That's actually part of the C out command.
But
Like you're just printing out another value. Like here, let me draw this. It's like me doing this. Hold on. I know your confusion right now. Like that next insertion operator or whatever it's called is actually just me doing this. Hold up. Let me write this like more to the side. Like if I had this, right? What would this print out?
A7.
That's a 1, but yeah. Sorry, my bad.
That's a 7.
There we go. This is just print out A1, right?
Yeah.
That's what this question is doing. It's printing out the 24 and then the 0. Like that second part, like this part right here is meant for printing. So 5. Yeah. Does that make sense?
Yeah.
Okay, cool.
You just need to know that an int is 4 bytes.
Yeah, basically. Yeah, you do have to know that it's 4 bytes. Yeah. I hope that we won't need to know like how much is a, I don't know. What are like some weird data types that we don't use often?
Wait, how are we supposed to differentiate between like a stream operator and a bit shift?
I think the way that it works is like it depends on the surrounding context. So like we're not outing the stuff inside like the first parentheses because it's an int, it's like an integer value on both ends of it. But since there's like a out all the way to the left and it's not like contained within parentheses, it treats it in like the out context instead of the bit shifting context and does it like that.
Yeah, I think the biggest thing is to look at the parentheses.
I just think it's kind of like a bullshit question. Like, you know what I mean?
I mean, I'm not gonna lie, that's like low-key, a lot of these questions are trick questions. So like, I mean, it just kind of is what it is.
Well, just to
let's see.
confirm,
Are there
the
like a
size
few
of-
more questions? Like maybe a couple more I can do because most people have left in person now, so I'm probably gonna get ready to head out kind of soon.
you
Also,
ex- Can you do 18, please?
18. Let me make sure I have the same 18 as you.
It's
Mine,
the one with the swappy boy.
yeah, one with the swappy boy. Okay, yeah. All right. Do you want me to just explain this one real quick? Because this one's like, I mean, I don't really see a visual helping. Do you want me
Yes,
to?
please.
Okay. So basically, what you're doing for this one, you see swappy boy. Tell me what the parameters are for swappy boy. What are you putting in?
You're putting in pointers.
You're putting in
of-
pointers, right? And what did I
Yeah.
mention a pointer was earlier in the PowerPoint presentation?
It points to a memory address.
It's a memory address, right? So really what you're doing is you're putting in 2 pointers, and that's why you can see in the swappy boy, you have the memory addresses, you have the ampersands to say their memory addresses, right? So basically what you have here is you're putting in pointers. Now what the swappy boy is actually doing then, if these are pointers, in order to actually change their values, you would have to dereference them. But because
Yeah.
we're not dereferencing, we're literally just switching what the pointers are pointing to. We're not switching the actual values at all. So that's why A is still 20 and A is still 10 and B is still 20 in that question.
If you were to dereference it, would it be 2020 like the output?
Yes. And also if you dereferenced it, you would have to like put in an actual value, or like you would have to dereference the other thing. Like if you dereference it, you can't set something that's dereferenced equal to a memory address. Does that make sense? So like keep that in mind.
Yeah, that's what threw me off a bit. So, okay.
Yeah. Is there maybe like 1 or 2 more questions that are like really dire?
Oh, wait, I have a question. Like the question about linked list in the midterm.
Perhaps I don't.
Hi.
For that, was it complicated, or like if it's super complicated, like I'll message you, but like how complicated is it?
It's like the really long one with the like.
Because I haven't actually looked at the midterm in like a really long time. So I would say like just like message that to me and like I'll explain it like via Discord, you know?
Okay, because it was something like also similar to the question 2 about the linked list on the
How does
practice exam.
swap B not point to? Well, no, and it wouldn't really matter what it points to because like it's just pointing to something. It's not actually changing the value still. Like if I say pointer C equals like address of A, right? And then I say and then I later on in a code, I like say pointer C now is pointing to address of B, but I don't actually do anything. It's not like it changes A and B.
I
Like
think
I think
it
the
does.
biggest, like I think the big thing there is just like realize like it doesn't matter. Let's see. 17, I see 17. I'll do 17. And did somebody say 25? 25. Okay, cool. I'll do 17 and 25. And then I'm probably going to call it quits for the night. If you guys have any other questions, you can message me. And like I said, I got to like change that stuff up real quick. And then I guess everybody takes the exam tomorrow. Best of luck. Yeah. And so, yeah, that's that. All right. So 15 and 17. Or 25 and 17. My bad. Let's see. Okay, let me go to 17. 17 is a little confusing for sure. I definitely want to write this one out. Just making sure whoever asked 17, it's the one with like the array of 10 zeros, right?
Yeah.
Okay, cool. So we have this array, and you need to know that when you're making an array, usually C++ does not have default values, but in this case, when you're making this array, it does have a default value. Basically, when you make an array, and I actually tested this in C-Line while I was like looking at this question, just to make sure this is how it works. If you like set, like if you have like an array of like 4.
Chris, your camera's glitching out.
Oh, it is. Let me, do you want me to like unshare and reshare? Maybe?
No, it's like glitching. I see like colors everywhere and shit all at once.
Okay, yeah, let me like undo it and redo it. Let's see. Video, stop video, and then start video maybe. There you go. Is it good now?
Yep, it's oh not never mind.
Let me try unplugging and replugging my camera maybe. There we go. Hopefully it's good. Okay, tell me if it starts happening again. But anyways, let's say you have like an array of 4 items and you do equals like 1. This array is going to basically become 1, 0, 0, 0. Or let's say you did like an array of 4 items and you did like 1, 2. This array is going to become 1, 2, 0, 0. I don't know if that makes sense to you guys, but like that's like just kind of how it works. So anyways, we have this array. It's an array of 10. And it's just set to that, right? So if we look at this array, we're basically gonna have 1, 2, 3, 4. Oh gosh, I need more space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is what the array looks like right now, okay? So let me look at the exact question again. Let's see. So now in the loop, right, we're basically setting the array pointer, the dereferenced array pointer, equal to I. Now, this array pointer, I'm just going to abbreviate it to array pointer, is just set to the array itself. Now, when you have an array pointer set to the array itself, what that means is it's going to point to the first item in the array. This goes with the whole concept of contiguous memory. Stuff in an array is basically all together, right? So when you're pointing to just an array, you just point to the first spot in the memory. So you're pointing this right here, okay? So then what we're doing is in the loop, we're dereferencing it, right? We're dereferencing the pointer. So now we're actually modifying the direct value of this. And we're going to set it equal to I. And then after we set it equal to I, we're increasing it. So for example, if I is 0, and we're going from I is 0 to I is 9, because it's from 0 to less than 10. So like, for example, when I is 0, we're going to set it equal to 0. And then we're going to actually update it by making it 1. Okay, and that's I is equal to 0. And then if I is 1, right? Basically, what we're going to do is we're going to say, okay, it's no longer 1. It's now, well, I is still 1. So it's actually still 1. But, and then we're going to and then we're going to increment it again. So, and now I1 is done. Now, if we follow this pattern, basically it goes down to I equals 9. When it's I equals 8, it's going to currently be 9. Camera's just killing itself right now. Oh, it's not showing enough of the board. Let me just. How about now? Okay, cool. So now, like if we follow this pattern, right? And we go to I equals 9. Basically, like it's going to be 9 at 8, right? So this would be I equals 8 actually. And then it's going to actually get reset to I is 9. And then it's going to get updated to 10. And then the loop is going to stop. So basically, when we print out the first piece of the array, which is like the 0th position, we're going to get 10. But then like we never edited any of this. because notice that when we were editing this array pointer, it was always dereferenced. So it was always just like, it was never being set to point to something else. It was always just dereferenced and pointing to the first object, and that's the only thing it was modifying. So everything else is still just 0. So that's why when we print out 9, it's still just 0. So you think like the answer is like 10 space 0 or something, right?
Yeah, that's it.
So hopefully that makes
So
sense.
it doesn't update anything except the first element.
Right, and that's because it's being dereferenced. And it's not ever like the actual memory address is never changing. It's just the value itself.
All right.
Cool.
See, I thought it was increasing each element by 1. And
Yeah,
they're all
yeah.
0. All right, thank you.
So yeah, of course. And I'll just do 25 now. And then I gotta like reset this room back to normal and then go home. So let's see. Let me look at 25.
Put like a 1 and use those brackets and get an array of 10 ones.
No, it would be like I explained it earlier. It would be look like this. If we change it to 1, this would be 1, and then it would be more zeros.
Okay, got it.
Yeah. Like I said, I literally tested this before this class because I was curious about that too. I was like, wait a second, how does this actually work? But yeah, that's how it works.
Okay, so I don't remember actually explicitly learning that.
Yeah, me neither. I
Well,
didn't.
I just.
A lot of the stuff I don't think we ever explicitly like learned, but like I don't know, maybe we did. Maybe we just weren't paying attention.
Sharon is not.
Let's see. So let me go to 25. I'll keep the recording up to this 25, and then I'll end it. All right. So for 25, I'll just explain it to you again. The reason it's undefined, do you see at the very bottom how it says delete and then it has array 2, but like it doesn't have the
Love you,
delete
Chris.
array? Huh? Was somebody saying something? I don't know. You like just cut out.
I think he said love you, Chris.
Oh, okay. Bye.
I don't know. I don't know, but he's already gone, so I
And-
can say it wrong.
Okay. I didn't even get to say love you too. What the heck? But anyways, so do you see how it has like delete array 2 and like it like doesn't have like the little brackets? Like whenever you have delete of an array without the brackets, it's always undefined behavior. That's the reason that answer is what it is.
Okay, but also on the second for loop, it's running 5 times, it's only like 3.
Second. Yeah. So I want to test that actually. I'm not like the reason that this is undefined is because of that last line. It's not because of that loop. But I would run that in code and test it to see the exact like just like without the deletes. I would see.
Typo or I'll
To me, oh no. Actually, that's only going to run 3 times. You know why? Because look at the plus plus I. So it's the plus plus is before the I. So it's actually going to do 1, 2, 3. 1. Hold up.
Okay.
1, 2. Wait, no, that's going to go 4 times, right? It's going to go 1, 2, 3, 4. So yeah, that would actually be perhaps an error, or perhaps it would just go to the next space in memory. I think that actually would go to the next space in memory, basically. After that array. But once again, like try that in C line. See what happens. I think, yeah, I have a feeling that would actually just go to the next spot in memory since it's contiguous. That was what I had to update. I had to update the contiguous memory stuff for like the vector. I gotta figure out where I saw originally that it wasn't, but I'll figure that out and update it. Anyways, I'm gonna stop recording. Thanks everyone for coming. Peace out. My voice is now dead, so oh boy. See you, Matt. You're welcome, guys. Peace.
Hey, Chris.